All right. Hey, hello. My name is Ryan Warzella, and I'm the Customer Experience Team Manager at Sure Controls, Inc. in Greenville, Wisconsin. And today I want to talk about capacitor reforming in variable frequency drives. What is it? Why should you do it? And who could benefit from it? So just start off with a little story. Maybe you're running or, you work at a manufacturing facility and you have a variable frequency drive that fails. Maybe this drive fails on the weekend. You don't have access to get a replacement quickly, but then you remember, hey, I know 5, 6, 7, however many years ago, we purchased a spare drive just for this instance. Great. You go to your storeroom, you take out that drive, you remove the defective drive, you put in the new drive, you wire it up, your maintenance team's ready to put power on it, you throw power on that drive, and if you get lucky, maybe the lights on the drive will turn back on, the drive will run, and your machine will be back up and running. If you're not so lucky, maybe you hear a loud pop accompanied by some smoke. What happened? That's not good, right? Now you've got 2 drives that are down and a machine that still isn't running. What happened? Your new drive, or maybe it was a drive that was sitting unused but still new, failed. What happened? So in a situation like that, what probably happened was the electrolytic capacitors inside that drive failed because they were sitting idle for too long. So if you look at an electrolytic capacitor, and this is just a very small version of what's going to be in the drive. There's capacitors that are across the DC bus filtering circuit in the drive. And inside the capacitor are going to be positive and negative plates. And those plates are going to be separated by what they call a dielectric layer. And that dielectric layer actually insulates the positive and negative plates from each other. It prevents those plates from basically arcing to each other and shorting out. And what could happen with an electrolytic capacitor over time is that dielectric layer can actually start to deteriorate. And if that deteriorates enough, you essentially have a short circuit condition between the plates of that capacitor. And if you were all of a sudden apply a large voltage to it, such as the case of just throwing power on that drive, you can actually cause internal arcing in the plates, and that capacitor can explode. Electrolytic capacitors, they like to have voltage on them at all times. That constant voltage is actually what keeps that dielectric insulating layer happy and healthy. In the case of a drive that may be powered down or never powered up, the longer it sits, that electrolytic capacitor, that dielectric layer inside that capacitor will actually start to deteriorate over time. And if it deteriorates enough, it'll lose its ability to insulate those positive and negative plates from each other, causing a short circuit condition. And that electrolytic layer, or the dielectric layer, can actually start to deteriorate, if that capacitor has been sitting without voltage for a period of 8 to 12 months. So a lot of variable frequency drive manufacturers actually recommend, if you have a drive that's been sitting idle without power applied for 12, 18 months or longer, the capacitor should be reformed. So what does reforming actually do to the capacitor? What reforming actually does to that electrolytic capacitor is it rejuvenates or rebuilds that dielectric insulating layer inside the capacitor. And the reforming process is such that you gradually over time ramp up the voltage that's being applied to that capacitor. You don't want to give it a large surge of voltage because then you can risk that capacitor shorting out and exploding again. So what the reforming device actually does is it's nothing more than a high voltage, low current, variable DC power supply. There are some other things in it that help the reforming process, but generally that's what it is. It's a large power supply. This particular unit can go up to 1,000 volts. So what this allows us to do is gradually over time increase the amount of voltage we're putting into that capacitor and helps kind of rejuvenate that dielectric layer. In the case of a common VFD, you'll either have a VFD that'll be a 230 volt line or a 480 volt line here in the US. You always reform the capacitor to the max DC bus voltage. So a 230 volt drive is typically going to have a DC bus voltage of about 325 volts DC, and a 480 volt drive is going to have a DC bus voltage of about 680 volts DC. So when you reform the capacitor, you're actually putting that higher voltage in. Most drive manufacturers will have a reforming procedure that can be found in the maintenance section of their manual. Some of them will just recommend, if the drive's been sitting for a year or longer, you can just apply, your line voltage to the drive, let it sit for an hour or two, and just doing that will reform the capacitors. That's not always feasible because not everyone's going to have the ability to put their spare drives to full line voltage. So that's where a device like this comes in handy. It just operates off normal 120 volt household current, which makes it portable. So, we can come on site and do all the drives in your storeroom or in your spare stock, and we don't need any kind of special power, don't need any kind of special additional safety equipment to do that. So if you're interested in having your capacitors and your variable frequency drives reformed, give us a call and we'd be happy to help you out.